Hey everyone, and welcome. Today we're going to dive into one of nature's most amazing displays. We're breaking down exactly what causes the northern lights. You've probably seen those incredible pictures, right? Green and purple ribbons just dancing across the night sky. It really does look like magic. But the real story actually starts about 150 million kilometers away, at our sun. So here's the big idea. At its heart, the aurora is basically a collision. It's what happens when these tiny, super-fast particles from the sun slam into the gases way up in Earth's atmosphere. To really get it, we need to follow those particles on their journey to us. So let's trace this whole thing back to the beginning. We're going to follow the energy on its long trip, all the way from the sun to our own sky. It all starts with something called the solar wind. You can just picture it as a constant stream of charged particles that the sun is always sending out in every direction, all across the solar system. Now, lucky for us, our planet has a magnetic field that works like a huge invisible shield. It's called the magnetosphere, and most of the time, this shield just pushes the solar wind safely around our planet. But, this shield isn't always shut tight. It really depends on the magnetic field that the solar wind brings with it. If its field points the same way as Earth's, our shield stays strong. But if it points the opposite way, well, that can open up a sort of magnetic doorway, letting all those solar particles pour right in. Okay, so once those particles get inside, what happens next? They get swept around to the dark side of the Earth, and they stretch our magnetic field way out, kind of like a giant rubber band. Eventually, that band gets stretched too far, and it snaps back. This slingshot action fires those particles at incredible speeds right back toward Earth, straight into our upper atmosphere. And this is when the light show really begins. Those super-fast particles are what create all the beautiful colors that we see. Let's take a look at how those different colors get made. So here's the key thing to remember. Our atmosphere is made of different kinds of gases at different heights. The color of the aurora depends entirely on which gas a particle hits and how high up in the sky that collision happens. It's actually pretty simple when you break it down. Green and red lights both come from hitting oxygen, just at different altitudes. And those really pretty purples and pinks, that's what happens when they hit nitrogen. That classic bright green color, the one you see in most photos, comes from particles hitting oxygen somewhere in the middle of that auroral zone, about 100 kilometers up. It's just the perfect spot where there's lots of oxygen for the particles to run into. Now, the red aurora is much more rare. It happens way, way up high, over 200 kilometers, where the air is super thin. Up there, particles hit oxygen atoms, and because there's not much else around, the oxygen has time to glow red. You usually only see this during really powerful solar storms. Then you have the most energetic particles. These have so much power that they can travel even deeper into the atmosphere. Down there, they crash into nitrogen, creating this beautiful pink or purple fringe right along the bottom of the lights. And all of this brings us to a really cool point. It turns out that right now is an absolutely fantastic time to see the aurora, and it all has to do with what the sun is up to. See, the sun's activity goes up and down in a cycle that lasts about 11 years. And right now, we are at the very peak of that cycle. It's called the solar maximum. That means more solar flares, more activity, and way more chances for us to see amazing auroras. And just to give you an idea of how active it is, scientists originally predicted this cycle would peak with a sunspot number around 115. While back in August of 2024, that number had already hit 216. This cycle is way more powerful than anyone expected. And that intense activity is happening as we speak. In late 2025 alone, we saw some huge solar flares. On December 6th, one of them launched a giant cloud of particles straight at Earth, which led to a strong geomagnetic storm watch. That's exactly the kind of event that lights up the sky. So, with the sun being this active, the big question is, where should you go to get the best view? Well, each of the best spots has its own pros and cons. Abisko in Sweden is famous for its clear skies. Fairbanks, Alaska is super reliable for seeing the lights, but it gets really cold. Tromsø in Norway is a great city, but you might have to deal with coastal clouds. And then there's Iceland, which has the most incredible scenery, but its weather can change in a minute. But no matter where you end up, the key things for success are pretty simple. First, get away from city lights into a really dark spot. Second, check the space weather forecast so you know when a storm is headed our way. And finally, be patient and dress warm, because you might be waiting outside for a bit. From the core of the sun all the way to the top of our own atmosphere, the northern lights are a real, visible connection between our planet and everything else out there in space. It's an amazing reminder of the powerful forces all around us, and a pretty good reason to just look up at the night sky.